Yeah, so today we'll be talking on variations. So here we have it. So in variation, there are 4 different kinds of variations. And the first one we have here is a direct variation. We also have our inverse one, our joint one, and finally our partial variation. So in this video, we'll be talking on direct variations. So when something varies directly, how do we come about that? So it says here that if by observation, as one quantity increases, the other quantity also increases. Or if a quantity decreases, the other decreases as well. We say they vary directly. What this is trying to tell us is this: if a quantity x, if it increases from 1 to 2, a quantity y would also increase from 2 to 4, or from 2 to anything, or from anything to anything. But what we are trying to say is that as one quantity increases, the other increases. In that sense, we call that form a direct variation, direct proportion. So, and then in variation, this is how we're going to be solving it, mathematically, and then in other forms. So we say if x varies directly as y, as in x varies directly as y. So this symbol here is a symbol of proportionality. So note the symbol, note how it's been written. So mathematically we have x equals k times y, or ky, where k is a constant of proportionality. You should notice here we've taken away the symbol of proportionality and we introduced our equal to sign and our k. Please note this. Note the difference between both. So the first thing we have here is a proportionality. X varies directly as y, and then mathematically we have it as x equals ky. So in any form of variation, any form of direct variation, this is how it has always been solved. So let's go into some examples to check some things out. So here we have it. Okay, k equals x over y, as in if you want to make your k the Sawyer formula. So let's try some examples. The first example we have here is a varies directly as b if a equals 3 when b is 15. Find the relationship between them. So here we have it. So write out our parameters first, the formula to use. So here we have a varies directly as b, and to remove our proportionality symbol, we introduce a equals kb, as in a equals k times b. But then our a is 3, b is 15, so we'll insert both into the first equation we have. We insert it into our a equals kb, so we have it say 3, a is 3, so 3 equals k times 15, b is 15. So now we want to make our k the substitute formula, so we'll divide both sides by 15. So here we have it, we'll have k equals 3 over 15. And if we should simplify this, we should have k equals 1 over 5. But then we're asked to look for the relationship between them. So this is how to present it. From a equals kb, a equals 1 over 5b, which is the relationship between them. This is the formula connecting them. If anybody asks you to find the formula connecting a particular variation, or the relationship between a particular variation, just find the value of the k and then put it back into the equation, and then you're done. So we'll move on to another example. So w varies directly as y squared. If w equals 75 when y equals 5, find w when y equals 2. Okay, so again we write it here, y varies directly as y squared. Now this time around it's not just y, it's not a, it's not b, the square of y. So as they vary, this means that when w is 6 and y squared is 8, when w is now 9, y squared would increase. That's what it's trying to tell us, not y, it's y squared that is being varied here. So we have it here, w equals ky squared. and then we have this thing, we have w equals 75, y equals 5. So the first thing we'll find here is our k. The first thing we'll always find in variation is our k. We need to know our constant of proportionality, the value for it. So we insert our values into the formula. We have 75 equals k times 5 squared, and that should give us 75 equals k times 25. And then we'll make our k, this substitute formula again. We have k equals 75 over 25. If you should present your calculator, you should have k equals 3. So again, let's write out the formula connecting them. So we have it as w equals 3y squared, as our k is 3. But then we are not done yet. We have to find w when y equals 2. When y equals to 2. So we have it here, w equals 3 times 2 squared, because we've already been given our new y, which is 2. So just put it in. We know our k already. So we just put it in as w equals 3 times y squared, which is 2 squared. And then we have it as w equals 3 times 4. And 3 times 4 is 12, so w equals 12. So it's as simple as that. We're done with the second question. Let's try out another question. So here it says, if the sum of x and y varies directly as the square root of z, when x is 2, y equals 3, z equals 9. Find x when y is 2 and z is 16. Wow. So here we have it as the sum of x. So it is the sum here that varies directly as the square root of z. The sum of x means x plus y. So x plus y as a single value is varying directly as the square root of z. That's the root z. So we have it here as x plus y varies directly as the square root of z. Look at how it is. Notice how it's been done here. So then I introduce my constant of proportionality and my equal to sign. We have it as this here. Wow. Now we are done. If you can just know how to derive the particular formula, then you are done in variation. The other parts are very, very easy. So, and then we will chip in our parameters. X equals 2, y is 3, z equals 9. So we have 2 plus 3 equals k times root 9. So this should give me 5 equals k times root 9. Here is what 3, though it could be plus or minus 3, but then we are using just 3 here. We are using the positive part of it, positive value. So 5 equals k times 3, and then you make your k the story formula again. We have k equals 5 over 3. So this is our formula connecting them. So x plus y equals 5 over 3 root z. Now my root z is not below, it's up. I could even write it as x plus y equals 5 root z over 3. The same thing. So, but then we have to find our x when y equals 2 and our z equals 16. So you just put in everything since we already know what our k is. So this will give me x plus 2 because y is now 2. X plus 2 equal to 5 over 3 root 16. My z is now 16. I was asked to find what x is when my y is 2 and my z is 16. So we have it as x plus 2 equals 5 over 3. Root 16 is 4. We need the positive part of the square root. So we have plus 4. So x plus 2, 5 over 3 times 4 over 1 gives me 20 over 3. So x plus 2 equals 20 over 3. Then if I want to collect the like terms, plus 2 will move to the other side to become negative, to become minus 2. So I have x equals 20 over 3 minus 2. So my final answer here would be 14 over 3 or 4 whole number 2 over 3. As easy as that. And then we have another example. Yeah, the first example here is the product of x and y varies directly as the square of z. When x equals 3, y is 12, z equals 6. Find z when x is 16 and y is 4. If we want to try this, let's wait a little, look at the question well. This is not even as difficult as the previous one. So here we have it. You try to interpret the question. The product of x and y means x times y or xy. So we have it as x times y varies directly as the square of z. Square means double, not double, a number multiplied by itself. When you multiply something by itself, that gives you the square of that number. So the square of z here is z squared, as in z times z, which is z squared. So we have it as x times y varies directly as z squared. And then we introduce our equal to sign up and our constant of proportionality. So x times y equals k times z squared. So our x is 3, y is 12, z is 6. We chip them in again. Okay, we can write it. You can write it as this: xy equals kz squared. So we have these, and then chip in your values. We have 3 times 12 equals k times 6 squared. 3 times 12, my calculator here is 36, equals 6 squared is 36 as well. So k times 36, and then I would make my k this substitute formula again. I would have k equals 36 over 36. So that gives me 1. So k here is 1. So x times y equals z squared, because 1 times z squared is still z squared. So that is our relationship. Our relationship here is xy equals z squared. Now we have to find z when x is 16 and y is 4. So we'll just put everything in, find z. That would be what? 16 times 4 equals z squared. So 16 times 4 gives me 64 by my calculator, equals z squared. So I can solve these in different ways, but then I would want to solve it this way: z squared equals 8 squared, because 8 squared is also 64. So that's because our distance are now equal, our powers, we can easily equate their base, since we have 2 and 2 as their power. So our z becomes 8. So z equals 8. You can solve in different methods. Again, you can just find the roots of both sides, find the square root of both sides. So that would be z equals square root of 64, which is also 8. So whichever we want to solve it, as far as your answer is 8, you're good to go. So you're done. So inverse variations, we'll treat these in our next class. So thank you very much for listening, and click the subscribe button to be updated for more videos.